Good morning, ladies and gentlemen. Thank you very much for joining us today to talk about the economic valuation of groundwater in Abu Dhabi. And I would like to introduce the speakers. Dr. Justin Baker, he was the lead author of the study commissioned by the Environment Agency, and Humeid Ganji, who is an environmental economist from EAD, and Professor Franz Lennart, who is associate professor at UAE University. And I would like them to present themselves. And afterwards, we will explain you why we decided to conduct this study, which were the results, and what comes next. So if you would like to introduce yourself, Justin.
Good morning, everyone, and thank you very much to the conference organizers and to EAD for hosting this session. It's a real privilege to be here. I couldn't be more excited to present some of the results of this work and to have this discussion. I'm a senior economist at RTI International, which is a nonprofit research and consulting institution based out of Research Triangle Park, North Carolina. A lot of my work is in natural resource management and environmental economics, including a hefty portion of work in the integrated water resource management space. I typically build models. I have a background in operations research and dynamic economic analysis. Thank you.
Yes, good morning, and thank you for the invitation here. My name is Franz Lennart. I'm an associate professor at the moment at the UAU. My subjects are soil physics and hydrology. I have conducted several groundwater studies in arid regions, as for example in Oman, and these groundwater studies served for the purpose of the management of the groundwater resources. Thank you.
My name is Humeid Ganji. I work as an economist in Environment Agency Abu Dhabi, and I think this topic is it is very important and very interesting to be explored further in the future. The aspect of adding another dimension to environmental issues and exploring some other aspect of it, like the economic complexity and then the social or cultural dimension to it in the future. Thank you.
Thank you very much. So why EAD decided to commission this study is quite easy to answer, because groundwater reserves in the country are depleting very quickly. So particularly in some areas that we call red zones, there is an inefficient use of groundwater, excessive abstractions, and this could be due to inefficient groundwater pricing. There are no markets. You know that groundwater is not traded. And we thought that pricing policies do not reflect water scarcity and do not provide economic incentives to conserve water. So if we could understand better the economic value of groundwater, we could use it in cost-benefit analysis and for other policy uses. And then we asked some experts, could you estimate the economic value of groundwater in dirhams per cubic meter? And could you also transfer some of your knowledge through training on ecosystem service valuation to not only EAD staff, but also to other experts and students from different universities in Abu Dhabi? So we asked RTI, who is the lead author, particularly Justin Baker and his team, to conduct this research. The research was also peer-reviewed internally in EAD and externally by local and international experts. And we would like to thank also all the organizations that provided data, not only from EAD, but also from ADWIA and the Department of Transport. So we are going to start already talking about the project and providing maybe some context to what is economic valuation of groundwater. But I think Justin would like to mention something.
Sure. So I'll be very quick if you can move to the next slide, please. So just a very, very brief overview. our evaluation study began with what is known as the total economic value framework. And this is a framework that allows us to look at the economic value of water through a number of lenses, right? So we know that water resources provide some market use value, right? So we use water directly to create economic goods and services. So in the agriculture sector, we're really evaluating what the market use value of that water resource is. However, there are a number of other non-market values that one could estimate due to the provision of that water resource, right? And so with groundwater, we're really looking at the kind of indirect non-market use value of water provided for forests. So there's a number of forest plots and forest stands in Abu Dhabi that are intensively irrigated. And so we wanted to understand what the value of those forests are, because these aren't forests in a traditional commercial sense that are used for timber products or pulp and paper, but they do provide nice cultural heritage value. They provide some level of biodiversity and species protection. They provide some road and infrastructure protection. So we wanted to understand what the economic value of these services are. And we also wanted to understand the option value. So an option value in natural resource economics refers to the value that I have, the willingness to, my willingness to pay to preserve a resource in the future for future consumption, right? So you can think about this as, how do I value my ability to maintain or set aside a certain portion of the groundwater resource for future consumption? And I can get into a little bit of that, but basically we used a recent effort to pump desalinated water into a groundwater reserve as the basis to understand what the option value is that the Emirate is willing to pay to preserve groundwater. Okay, so we conducted this economic assessment to come up with what I call value curves, which essentially give us the demand for water by different sectors. And we built a hydroeconomic optimization model. So hydroeconomic, meaning that it's grounded in a kind of a hydrologic model that gives us kind of a dynamic flow over time of the groundwater resource. And we used all available data to build this hydrogeologic schematic of the groundwater system. There's some limitations there that we can discuss later. But then that was coupled with these demand curves for water in the different sectors that we're looking at. And then we used a traditional dynamic optimization or optimal control approach to look at the value of water over time under different simulations.
I will take you a little bit back to why we are commissioning such a study. So basically, there are certain environmental, let's say, challenges that have welfare effect on people. So if we think of groundwater, there are certain implications, such as natural resources scarcity, and then the air quality, and another thing is the pollution from desalination activity and the loss of marine biodiversity. So we think of economic as an interesting framework to be used to explore possible future policy opportunities that could be discussed with the leadership. And of course, it is also important that we make sure that we are sending the message to people that although they don't have to pay for groundwater, it doesn't mean it's for free. There is a cost associated to it. So the opportunity cost of being exhausted, and then if we do nothing about it with time, the value per cubic meter of water is going to be much higher and higher. And then again, I would like to stress the point that there are some certain social consequences, and the groundwater is multi-faced challenge. It stretches over many generations. And if we take another dimension, is the socio-cultural, as the value of and the preference of water are deeply rooted in the local community. So alongside with the economic valuation, I think there are other approaches that are also equally important, like, for example, awareness campaigns and reaching out to the public, which we are already doing in AAD with our outreach programs. Yeah, so this is my insight on how and why we are seeking to improve and let's say innovate the way we are approaching environmental challenges?
Okay, from my point of view, this is a very important study. First of all, I would have to say that I was not involved in the study at all, but I consider this as a very important approach because it allows to visualize the value of our natural resources. And the visualization and understanding of this value is the first step to really set up some policies and strategies to sustain these resources in a way. If you look at this approach, this is the combination of a geohydrologic model with economic approaches and a joint optimization of the whole thing, then it is very clear that the realistic description of the resource itself is the basis for a realistic economic valuation of the whole thing. That means if we describe the groundwater resources in a way that they are really existing, we will have a very good outcome. If this is not the case, our outcome will be very weak. And this depends on data. We need to know a lot of information about the groundwater resources. This is not only where are they, this is also how much really is there and what is happening if we are having, for example, a saline freshwater interface as it is the case here in many parts of the UAE. Saline water has a higher density than freshwater. If you pump the freshwater interface, you will have an acceleration in the mixing between the saline and the freshwater. And the outcome is that you will have a deterioration of your freshwater due to an increasing salinity, and finally you cannot exploit as much of the freshwater as you initially thought. So that is something of the major obstacles that I do see here. We need more realistic models, and to get more realistic models, we need more data on the natural resources that we are talking about.
Thank you very much. And Justin, before we tell the public what the economic value of groundwater was, can you tell us a bit which were the challenges that you found to produce that result?
Absolutely. So the primary challenge was data availability, both on trying to build this hydrogeologic framework that represents the groundwater system within Abu Dhabi, but also in trying to determine what the economic value is for certain activities. So the agricultural sector, for instance, it's quite difficult to understand what the kind of producer profits or producer benefits are of current agricultural production practices, because there are a number of inefficiencies built into the system. Luckily, we were able to acquire a fantastic data set from the Farmer Services Center where they had sort of built up kind of optimal farming practices and essentially gave us budgets for certain cropping activities. So that allowed us to build a really rich data set representing production possibilities in agriculture in Abu Dhabi. And that gives us a really nice, meaningful economic value metric whenever you combine profit conditions with groundwater actually pumped to irrigate these farms. The other challenge was in the forestry sector and deriving these non-market use values. The challenge there is that with resource limitations, we weren't able to go out and conduct an original survey asking people how they value or what they're willing to pay to maintain these forests. So we had to rely on what we call benefit transfer, which is essentially taking comparable studies and comparable regions that have looked at similar ecosystem services and transferring the economic values that they've estimated to local conditions. And so that was our approach on the forest side, but it did take some time to identify those relevant studies and to come up with a meaningful methodology for deriving these values.
Thank you. And now, what was the economic value of groundwater?
So what we have here in the table and in the graph below, we have represented the absolute kind of total economic value of the groundwater stock over time in the table. And then in the figure, what we have is the marginal value. So the marginal value can be thought of as an implicit price, right? So we can think about this as under kind of optimal market conditions, what would the price of groundwater be? It would be somewhere in this range likely, and that range begins in year 1 of our simulations between 7 and 9 dirham per cubic meter. So what we show is that that marginal value increases over time. So the longer we go through our simulation horizon, the higher the marginal value is. This is consistent with natural resource economic theory. And note that the marginal value also rises with the discount rate, right? So we looked at 3 different scenarios at 3, 5, and 8% discount rate. And those scenarios actually give us very, very different results. With higher discount rates, that means you essentially care less about, or you place less value on future consumption, so you extract more now and save less of the resource for subsequent years. Whereas with a lower discount rate, you are sort of more cognizant of the opportunity cost of consuming that resource now versus waiting an additional year or waiting an additional 5 years or 10 years, et cetera. So over a 100-year simulation time frame, the discount rate assumption makes a huge difference, not only in our total economic value, as we show in the table there, but also in our estimated marginal values, and also in our kind of optimal extraction rates. We find with higher discount rates, we actually show much more rapid depletion of the aquifer.
Thank you. And although I'm the moderator, I'm going to explain something. Because Humaid was very involved in this project, but then he had to go to the military service. And then we took over, and we were trying to define which could be the right discount rate to use for the project. And what we did is we asked other entities, because we don't yet have guidance from the government of Abu Dhabi regarding which social discount rate to use, for example, for environmental projects. So what we did is we asked other organizations in Abu Dhabi who were also using discount rates. We prepared an issue brief with all the information available, which models were used also internationally to define the social discount rates. And what we find out is that 5% could be a proper discount rate to use. However, this is a discussion that maybe we need to maintain also in the future, and to establish a common social discount rate for all projects in Abu Dhabi, so that we could compare them much more easily.
So we can say also that these results are not set in stone, and it really depends on the policy context, or what are different management options that we are looking to seek for. So it could be updated with different additional scenarios. But what is also important is that we are also looking into building a network around similar exercises or future exercises with different policy recommendations that will strengthen in building local capacities around the topic.
Thank you. And how are we going to apply the results of this study?
So let's say the information that is like the output of such exercise could actually provide us with some interesting policies. We have here a list of 6 possible policies. And one policy is groundwater extraction fee beyond an agreed threshold. So there is a specific threshold that is defined through using different tools that we are yet to be implemented, which is crop calculator. I think AAD is working with DIFC and other agencies, which is going to be used to define what could be the optimal water for a specific farm based on the information on their crop pattern and the different climate parameters. And of course, there is also another project that is well inventory and metering that could complement such a policy. So if a specific farm uses water beyond the agreed threshold, then they could be charged the implicit price of groundwater. And the second policy is regulating extraction from certain groundwater pools. So if we can find that there are some certain evidences on specific pools that the cost of actually extracting water there is higher than the actual production or the benefit that we are gaining from, so then we can impose certain command and control, policy like no more extraction in that specific zone. And of course, there is third policy that is additional groundwater injection. So it could possibly be used also to define specific strategic zones where there could be injection of groundwater on those specific zones where we can see that it could yield in a specific positive benefits. And of course, there is policy 4, which is if you can flip the...
Oh, sorry.
Yes. So it is about investments to improve agriculture and forestry irrigation efficiency. The output of the research could be used also to, if let's say we have a specific strategy to do certain investments, targeted investment, so we can assess whether the specific investment is going to yield in a benefit that could outweigh its cost. So it improves, let's say, the decision-making process. So it bridges the science and policy gap. And then the fifth possible policy could be a targeted decommission of forests, or let's say, in another way, let's say we could target decommission of use of water for a specific forest. If there are certain alternatives that could be used, and then we can assess these alternatives, like the use of treated sewage water. And policy number 6 is it's another example of where we could actually make the output of the study could be used by the users rather than directly by the different policy agencies. So the user could have an information on the implicit price of groundwater, where they could have a ground to establish some sort of negotiation around tradable permits. So you establish an overall cap on a specific user group, and then those users could trade the right to extract water among each other, with the hope that it could improve the productivity of different users. So a user that doesn't have a specific need of a specific amount of water based on his, let's say, understanding of that his crop is not so water intensive and so on and efficient, and then someone else that could see an opportunity of using that permit to extract water for his best interest, then we assume that in this policy we are expecting that it could actually improve the productivity or the use of a resource, which improves the value of groundwater. So this is my general comments on the 6 proposed policies or possible policies.
Mm-hmm.
Well, maybe comment on that, especially the irrigation efficiency, yeah? Talking about the irrigation efficiency that I have seen so far in the UAE, the irrigation efficiency is pretty low. It is usually less than 50%. So the improvement of an irrigation efficiency due to the irrigation management, that is what it is actually that needs to be improved, would really contribute to the whole economy, because the agricultural output would go up, yeah? And we would get a much better value of return for the water that we put into the system. This is especially true for farms that are over-irrigating on a commonly used groundwater body, because if you are over-irrigating on a commonly used groundwater body, as it is the case here in the UAE in many places, you have a return flow which is occurring to the aquifer system, and this return flow brings additional salts to the aquifers. So the over-irrigation is deteriorating the water quality in the aquifer systems, which is further finally decreasing groundwater quality, and therefore in the end you cannot use the groundwater anymore for irrigation without treating it. Yeah? That is something which would be very important if there would be a policy that is really aiming at this problem.
Thank you, Franz. And Justin, would you like to add anything? And particularly, I think there was a discussion yesterday about the link between tradable groundwater permits and water budget. But if you would also like to talk about any other of the policy options, or
So going back to the water budget, which was discussed in the very first panel, the first day, this idea that you have an overall kind of integrated framework to look at water resource management across Abu Dhabi, and you understand kind of the supply of water and the demand across different sectors. A tool like this, or a framework that allows for tradable groundwater permits, fits in with that very nicely, because you establish an overall cap and potential consumption across different user groups, and you allow individual users to find inefficiencies within that. So if a relatively high-valued farm has a permit that is typical of most permits that are issued, but they would derive a high value from additional groundwater, they can essentially purchase that right from another user of the resource. And so this perhaps less efficient, lower valued farm would give up the right to pump, which would be bequeathed to the higher valued farm. So that's the way tradable permits work in this context. This is a growing area of emphasis in the U.S. and elsewhere. Tradable water permits. We have several active water markets in the U.S. and I tend to think it can provide some opportunities to increase efficiency and overall consumption of the resource.
Mm-hmm. Thank you, Justin. And going back to the value, how does it compare with other similar studies in other countries?
So maybe I should back up and say that this is a truly unique study, and that very few empirical modeling efforts have looked to derive the kind of total economic value of groundwater resources. So there's an entire framework that's been published, the total economic value framework that I mentioned, but very few studies have tried to apply this in reality, in part because it's very difficult. And in fact, most of the modeling studies that you see are really looking at economic differences between scenarios, right? So let's look at the costs and benefits of a major infrastructure investment project, or let's look at the economic costs and benefits of policy alternatives. But here, we were really just trying to understand, under baseline conditions, what is the economic value of water? Now, that said, what we found was this value ranging 7 to 9 dirham per cubic meter is somewhat within the line of what we see elsewhere. So FAO released a report that showed roughly 3.5 to 4 dirham per cubic meter. So values in Abu Dhabi are slightly higher, but they're slightly higher for a couple of reasons. First off, we are including that option value of maintaining the resource over time, and we're including these ecosystem service values. But second, and perhaps more importantly, given that this is an arid region, we would expect the implicit price of water to be higher because it's more valuable on the margin to agricultural producers. Agricultural producers really need the water here, as opposed to countries where perhaps the incremental economic value of applying an additional cubic meter of water to your farm would not really provide much in the way of additional revenue.
And if you would like to do this study again, which recommendation would you give to us in terms of maybe where we have to improve access to data or other things that could help us maybe to even obtain more accurate results in the future?
Right. So I mean, we've discussed the limitations on the hydrologic data, so I won't focus there. But I think better information on current irrigation rates of date palms and other forest species would really improve the modeling framework. We're using sort of average irrigation assumptions built off of a data set that EAD had provided. So improved information there would certainly help. I think if we're really building a model that's looking 100 years into the future, it's important to consider climate change and climate impacts, for instance, on crop yields. That would require a fairly major study in and of itself, but I think it's important. So those are the two things that really come to mind for me.
Mm-hmm.
There is some good news about that, because we are conducting at present a big study on the water consumption of date palms. The outcome should be how much water do date palms really need to develop 100% or 90% or 80% yield potential. And this is a large-scale study on 30-year-old date palms, which is conducted on the Alfoa research farm here by now. So in 1 year, we should have some results on that.
Mm-hmm. Thank you. And Franz, I have a question. I think that you have worked in Oman also to do some optimization of water use.
Yes.
Could you just tell us something about what you found and how it relates to the work here?
Well, we conducted a very large-scale study in the Sultanate of Oman. The problem there is the groundwater over-abstraction in an agricultural area called the Al-Batina. And the over-abstraction leads to the irrigation with saline water, and as a consequence, we have the dying of the farms. So the people abandon the farms and they move further inland to set up new farms. What we did is we developed a water management tool which was representing the entire natural and agricultural system. And the purpose was, how can we reduce the water consumption, and what kind of approaches need to be here set into place to manage the water efficiently. And one of the major components of this study was a three-dimensional density-driven groundwater model that we set up. And this groundwater model was used to visualize what it takes if we want to bring the natural system back into balance. And the outcome was really exceptional. Once we run the model, it became clear that it would take almost 400 years for the natural system to return into balance if you stop the pumping right now. Yeah? So this was for the ministers of agriculture and fisheries and the minister of regional municipalities and water resources, something very harsh, yeah, because they could really see if they continue doing what they are doing now, then it would take generations to the natural system to return here into balance, and that would lead to the entire abundance of these Al-Batina region with respect to agriculture. Yeah? So simply meaning in 10 to 15 years, no more agriculture would be possible there. Mm-hmm. The problem there is not the study and not the outcomes of the study. The problem there is the implementation of the results and the consequences that such a study has, because these results would lead to consequences that are highly unpopular. And the enforcement of unpopular measures, yeah, is something which is very critical, and it is clearly not in the hand of the scientists who are conducting such a study. Yeah? But this is where, well, we need to improve the things. Yeah.
Mm-hmm. So thank you very much. I think there are many challenges, but also there are many achievements. And I've seen that the public has some questions. So if you want, we can move into the questions unless you want to add anything else. Mm-hmm. So the first question is, do you think the estimating economic value of groundwater at 7.5 dirhams is contradicting with the concept of groundwater as precious and as strategic reserve for the Emirate? Anyone wants to take this question?
So my answer to this question would be, it is the methodology that is used in economic theory is basically it is basically based on how the resource is used. So let's say, if you take specific farms, the use of resource is, and the price of commodity and the cost of production have a big implication on the value of groundwater in agriculture industry and the use of groundwater in agriculture industry. Unless it improves the efficiency or the production cost drops, let's say, and they become more productive, then the value of groundwater will be contingent to the change. So, but of course, there are some sort of intrinsic value, let's say, to the groundwater, that it is so valuable and precious as a natural resource, but that's not how economic try to cover or try to answer the question of how much is it, or what is the value of groundwater according to its use and its, of course, non-market value. Mm-hmm. So I don't know if Justin can add a little bit on that.
Sure. So we did our best in developing this dynamic framework, and the reason we chose the methodological approach that we did is because it actually does include directly the opportunity cost of using a resource today versus consuming it in future periods, right? So it's already kind of imposing this scarcity value of the resource. Also, we looked at the capital costs of the recent groundwater injection project in Abu Dhabi, making the case that, well, this is sort of society's willingness to pay to preserve water on a per cubic meter basis. And so we called that the option value. So actually within our model, we're placing a value on maintaining groundwater reserves, right? So this non-use value of storing water as a strategic reserve competes with these direct use values. And so we did our best to try to account for that, but it's a very good question. Thank you.
Mm-hmm. Another question is, the curves presented for a discount rate of 3% for 26-year model, the value was beyond 20 dirhams. Is that the net present value? I don't know if whoever asked this question can clarify.
So the net present value is provided in the table, and then below we show how the implicit price or the marginal value of groundwater increases over time on a per cubic meter basis.
Mm-hmm. Another question is, does the model take into consideration the distance of groundwater available from the desalination plant?
We break groundwater down into 3 different pools: freshwater, brackish, and highly saline. And the highly saline and the brackish portions, we do require a certain percentage of that to be treated. So we are including some treatment costs in our overall cost curves of extraction.
Thank you. And last question for Franz. Did you get any initial data for palm needs?
Well, there are data, yes. They are not published yet. And it is pretty difficult. One should think that the people would know how much water date palm really require. This is simply not the case. It is virtually a big range which is published, ranging from 60% ET0, which is the so-called grass reference evapotranspiration, to 100% ET0. And this is a big difference. Yeah? And there is a big lack of systematic studies in this field. And this is what we are doing now, and we actually have some interesting results, but we will need to confirm the results before we publish them. Yeah? Because if you put this into something that a farmer could apply and you are wrong somehow, the palms deliver less yield and they suffer, you will have a major problem. So this is why we are going to be really cautious on this matter.
Thank you very much. And there is a last question that I suggest that we provide information directly to the person who made it, which is about the constituent elements of social discount rate. As I said, we produced an issue brief where we explained the international best practice. We compared also with how other countries were setting the social discount rate, and what was the practice also in Abu Dhabi. We will be happy to share this issue brief with whoever is interested. And we have finished already for today. I thank you very much, the panelists, for their very, very interesting insights, and the audience for your interest. And we are available if anyone needs anything else at the Environment Agency. Thank you very much.